Welcome to this explainer. Today, we're going on a seriously epic quest to try and grasp the true, mind-bending scale of our universe. We're going to start right here on Earth, our home planet, that tiny blue dot floating out there in the immense cosmic ocean where literally every human who has ever lived has resided. But from there, we're going to zoom way, way out, pushing past the familiar, all the way to the very edge of reality itself.
Right, let's dive right in. By starting on our tiny blue dot, we can anchor ourselves with some familiar concepts before we zoom out to the completely incomprehensible limits of space. It's incredibly difficult for the human brain to really process the vastness of the cosmos, so I want you to keep this central question in mind as we go. Just how far does our influence actually reach? That's going to really help ground us as these numbers start getting staggeringly large.
So, Section 1. Leaving our planetary home. The local commute.
Let's start our journey by just stepping off Earth for a second and looking at the actual distances to our closest neighbors in the solar system. Our very first marker on this cosmic road trip is the Moon. It sits about 384,000 kilometers away. To put that into everyday terms, if you were to hop in your car right now and drive straight up into the sky at a highway speed of 100 kilometers per hour, it would take you over 160 days of non-stop driving to reach it. You'd absolutely need to pack a ton of road trip snacks for that. And from that lunar vantage point, Earth is just this fragile sphere of blues and greens floating in total blackness.
Now, as we continue outward and look toward the sun, our earthly measurements kind of just break down. They fail us entirely. So we have to introduce our first cosmic metric milestone, the astronomical unit, or AU. This is equivalent to about 150 million kilometers. Instead of dealing with millions and billions constantly, which gets pretty tedious, astronomers use the AU as the standard measuring stick for distances inside our solar system.
Take a look at that massive number 19. If you swapped out your car for a commercial jet flying at a cruising speed of 900 kilometers per hour, it would take you 19 solid years to travel that one single astronomical unit to reach the sun. 19 years, literally non-stop flying. And yet, this fiery behemoth manages to provide life-sustaining energy to our planet from that incredibly vast distance.
Venturing past the sun, we set our sights on our enigmatic red neighbor, Mars. And check out this wild variance. At its absolute closest approach to Earth, Mars is about 54.6 million kilometers away. But because of orbital dynamics, when we're on opposite sides of the sun, that expanse stretches up to a massive 401 million kilometers. At that maximum distance, our hypothetical jet plane journey would take upwards of 50 years. This constantly shifting distance is exactly why you always hear about those strict launch windows in the news whenever we send rovers to Mars.
Okay, Section 2. The solar system's edge. Probes and icy frontiers.
Let's move to our outer neighborhood, crossing billions of kilometers into the deep freeze of the solar system. We measure a lot of these extreme distances by looking at the speed of light, which travels at a mind-bending 300,000 kilometers per second. Now, light reaches the moon in a literal heartbeat, just 1.3 seconds. It takes 8 minutes and 20 seconds to reach us from the sun. But to race across the vacuum all the way out to the edge of our solar neighborhood at Neptune, that takes over 4 hours and 15 minutes. Neptune sits roughly 4.5 billion kilometers from Earth.
Which brings up a fascinating question. How far have we physically reached into the stark void? Well, that brings us to Voyager 1. Representing humanity's insatiable curiosity, this little probe launched way back in 1977. Running on computer memory smaller than a modern car key fob, it has traveled an unbelievable 22 billion kilometers from Earth. It's the farthest human-made object from our planet, operating out there right now as a silent wanderer in the cosmic sea.
Back in 1990, at the suggestion of the legendary astronomer Carl Sagan, Voyager 1 actually turned its camera back toward Earth from a distance of about 6 billion kilometers. It captured the iconic pale blue dot photograph. Our entire planet appeared as a tiny, almost invisible speck of light. Carl Sagan poetically reflected on this image, giving us this deeply humbling reminder of our fragile existence and really our absolute responsibility to protect our only home.
Moving on to Section 3. The interstellar neighborhood. Leaping between the stars.
At the very fringes of our solar system, past a massive icy barrier known as the Oort cloud, we cross the heliopause. Basically, this is where the sun's influence finally wanes, and we enter the true interstellar medium. So, the crucial point here is that as we start looking toward other stars, we have to change our measuring stick yet again. The astronomical unit just completely loses its practicality here. The numbers simply get too big. Instead, we upgrade to the light year. It's exactly what it sounds like, the total distance that light can travel in one single year.
Let's test drive this new metric. Let's look at the closest star system to our Sun, Alpha Centauri. It sits 4.4 light-years away, which is roughly 41.3 trillion kilometers. If Voyager 1, which remember is screaming through space at 17 kilometers per second, were aimed directly at Alpha Centauri, it would still take over 70,000 years to reach it. That fact absolutely underscores the unfathomable challenges of interstellar travel.
Now let's see how this builds when we consider our entire galaxy, the Milky Way. This vast spiral is about 100,000 light-years in diameter and filled with hundreds of billions of stars. Yet our entire history of radio broadcasts forms a tiny 100 light-year bubble. Think back to that central question we asked at the very beginning. How far does humanity's voice reach? Well, in the grand scheme of the galaxy, our sphere of influence is practically an undetectable whisper. Anyone outside that tiny, tiny slice would be entirely oblivious to our existence. To them, it's as if humanity never existed at all.
All right, Section 4, Galaxies and Cosmic Superclusters, the Cosmic Web.
We're leaving the Milky Way entirely now, stepping out into the silent, almost incomprehensible wilderness of intergalactic space, where our whole galaxy is just a single speck in a grand cosmic library. We're zooming out exponentially. First, to our local group, an assembly of over 50 galaxies spread across 10 million light-years. Zoom out further, and we find the titanic Virgo supercluster, thousands of galaxies stretching 110 million light-years. And zoom out once more, and we arrive at our staggering galactic home on the grandest scale, the Laniakea supercluster.
Laniakea. It literally translates to immense heaven in Hawaiian, and honestly, they hit the nail on the head there. It contains the mass of 100 million billion suns. This supercluster is a gravitational masterpiece, bound together by a mysterious region of space with a massive pulling force known as the Great Attractor. In this immense web, our entire Milky Way and our local group are just infinitesimally tiny components caught up in this grand sweeping motion.
Which brings us to our final stop, Section 5, Beyond the Observable Universe, the Edge of Reality.
Reaching the absolute limits of our cosmic exploration, we finally hit a wall. The edge of the observable universe is an astronomical marvel stretching about 93 billion light-years in diameter. But this brings up a genuinely fascinating paradox that completely challenges our everyday logic. Think about it. If the universe was born in the Big Bang 13.8 billion years ago, how on Earth could it possibly be 93 billion light-years across? Shouldn't light have only had 13.8 billion years to travel?
Well, the answer is cosmic expansion. Space itself isn't static, it's stretching. Think of it like raisins in a loaf of bread baking in the oven. As the dough expands, all the raisins move further apart from each other. Ever since the Big Bang, the actual fabric of space has been expanding, increasing the physical distances between celestial bodies. And because space itself is stretching, some distant regions of the universe are literally moving away from us faster than the speed of light.
Because those distant regions are expanding away from us faster than the speed of light, their light will never, ever reach us. They're forever placed completely out of our view. And this leaves us with a deeply humbling realization to wrap up on. What invisible galaxies, what unseen planets, and what infinite mysteries lie retreating endlessly in those unobservable depths. The observable universe might just be a tiny, tiny fragment of the entire cosmic expanse. I'll leave you to ponder that immense reality. Thank you so much for joining me for this explainer.